Anthropic's Fable 5 quietly downgraded some answers with no refusal and no warning at all. So how do you know anything your agent tells you is real? This is the Agentic Daily Brief. And the Fable story got its ending overnight. After nearly 3 weeks with the US government blocking public access to Anthropic's two most capable models, Washington lifted the ban and Anthropic began switching global access back on. The trigger, back in June, was Amazon researchers who found a way around one of Fable's safety guards. To get back online, Anthropic says it retrained a classifier, a filter that catches the bad request, and now blocks the technique in more than 99% of cases. Though plenty of people still read the original ban as political muscle, not real security. One more from the wires. Cloudflare, which sits in front of a huge slice of the web, says that from September it'll block AI crawlers by default and charge them when the content actually creates value. If that holds, the free scraping that feeds every model and agent just got a price tag. Okay, back to that silent swap, because it's the cleanest version of a problem I think a lot of you are quietly living with. You run a model in production, you benchmarked it, you have your eval suite, a fixed set of test prompts you score to catch when quality slips. And the whole thing rests on one assumption. The model you tested is the model answering your users. Fable 5 broke that assumption. For requests that even looked like frontier AI work, biology, cybersecurity, Anthropic's plan was to quietly reroute them to an older, weaker model or degrade the output. And here's the part that got me. With no visible refusal. No signal at all. Think about what that does to your monitoring. A refusal you can catch. You alert on it, you page someone. But a silent downgrade just looks like a normal answer that happens to be a little worse. It sails straight past every check you have. A refusal you can alert on. A silent downgrade is a regression with the alarm wires cut. What do you actually do? The fix here isn't clever, it's stubborn. Keep your own golden set of prompts with known good answers and rerun it on every release. Treat a new model version, even the same name on a new day, as, something that might have broken, not a free upgrade. Because whether it's a quiet swap or, like Fable, a sudden government shutdown, the thing under your app can change without telling you. That's the model going wrong from the outside. But here's the failure that surprised me more, the one that comes from inside, when the model is behaving exactly as designed. Picture an agent that calls a tool, gets a small error back, and retries. Fine. Except it retries with a slightly different request that's also wrong. And again. Each loop burns a little more compute, until a tiny API glitch has become a full outage. Nishant Gupta, a tech lead at Meta's Superintelligence Labs, gave a talk on this, and his line stuck with me. When people hear AI failure, they think hallucination. But he says hallucinations are the least interesting failure. The dangerous ones are, infrastructure, retry storms, runaway loops, cost explosions. The model makes one small mistake, and the plumbing around it turns that mistake into a disaster. His rule is one sentence. Never let the model directly touch production. The model proposes an action. Then a plain code layer, deterministic, no guessing, checks it. A policy engine approves it against your limits, and one gateway is the only thing that actually runs it. The model suggests, the platform decides. You can see this shape in real builds. Amazon's healthcare claims pipeline wraps its agent in an ordinary supervisor that validates every step before anything commits. Same instinct, different team. An agency called Ogilvy runs its chatbot's guardrails in plain code before a single word reaches the model. The catch, and Gupta's honest about it, every one of those boundaries is code you now own and have to keep correct. You're trading some of the agent's freedom for a blast radius you can actually reason about. Which leaves the hardest question of the three. If the model can go wrong quietly and the plumbing can amplify a small slip, how do you ever check the work fast enough to keep up? Hamel Hussain has spent 3 years on evals, and he's got a phrase I keep repeating. Hard to eval is a product smell. His point is sharp. If an AI output is hard for you to verify, it's hard for your users too. And a user who can't verify an answer just redoes the whole thing by hand to check it. Here's where it bites. Generating code is basically solved now. The bottleneck moved to verification, to trust. One write-up calls it the audit tax. Your agent writes the pull request in 90 seconds, and then you spend 90 minutes reading it line by line to decide if you believe it. And it's not paranoia. One benchmark report found AI-written changes take more than 4 times longer to review than human ones, because they always look clean and confident, whether they're right or wrong. The eval you can't run cheaply is the tax you pay by hand forever. Hussain's flip is design the output to be checkable before you build fancy evals. Don't emit one opaque answer. Show the query it ran, the sources, a breakdown you can sanity check, and a flag on anything it couldn't verify. Make the check fast, not a full redo. One wrinkle though. A lot of the loudest voices here are also selling the fix, the keep your reviewer independent argument. That the model writing code shouldn't be the one approving it comes partly from a company that sells exactly that reviewer. The idea is still right, just weigh the mechanism, not the pitch. My read, pulling these together? The work across all three, evals, guardrails, checkable outputs, is really one job. Making the invisible visible before it costs you. Before you go, one thing worth trying this week. Pick your most used agent and pin a golden set. 10 real prompts with answers you know are good. Run it today, then run the exact same set next Monday. If the scores move and you didn't change a thing, that's your silent swap, caught early. And if you want a bigger frame, there's a talk by Greg Eisenberg, AI agents are the new SaaS. His one idea worth carrying. With an agent, the product isn't the tool, it's the job. You're not selling software a team could use, you're selling a task they no longer do by hand. Changes how you'd even scope one. So, back to where we started. Fable 5 answering quietly wrong, an agent looping itself into an outage, a clean pull request nobody can trust. None of it announced itself. The danger was never the loud failure. It was the answer that looked just fine. That's the thing to watch for. That's today's Agentic Daily Brief, brought to you by Agent Native Engineering, open knowledge for building and running AI agents. The full write-ups with their sources are at agentnativeengineering.com. See you next time.